Alright, in this video I'll be going through the last factorial digit, and it's the non-zero. So the difference between the first digit factorial and the last digit factorial digit is that in those cases, whatever the last number is whatever we're going to be using. Whatever it's what we're going to be printing out. However, this is where we have an exception, non-zero. Non-zero meaning that if whatever our number is going to be, if there's a zero at the end, ignore it. Keep going, keep going, keep going until you get a number. Until the number is a non-zero. That's basically the way this problem is gonna be going. So I have an example right here. Let me move this one out the way real quick so we can see it. This example, like I had mentioned, we would have an input of 5, and that 5, when we have the factorial of 5, 5 is 4, 3, 2, 1, we're going to get 120. However, because we are talking about non-zeros here, we're going to be outputting the number 2. Here, this is where I mean about that 0 having to be ignored. And that's kind of how we're going to be going here. I'm going to be going through like 3 more examples over that. But for right now, that's how we're going. So in the understanding portion, building onto the previous example, again, we are taking an input of an integer as well as outputting an integer. And that's how that's going. And now moving over to the matching portion. Out of the matching portion, what we have here is we have the equation n times n minus 1. So of course we're taking our number, multiplying it by number by 1, subtracting it by 1. And that's pretty much what we're looping through until we get 1. So again, I have some examples here. So I have 4 being my number. I will go ahead and subtract 4. I would have 4 minus 1, so 4 times 3 is 12. Moving on to that 12 times 2, which would be 24. 24 times 1 is going to be 24. However, in this one, I see that in this case, there is no 0. So what happens in this situation? Because if there's no 0, we print out the number 4. This one, the factorial of 5, I did print this out all the way through, leading all the way to 120. 120, like the previous example, the first example, excuse me. I'm only printing out 2. What about factorial 6? Go through that process right here, where I am ultimately left with 720. What's going to be my output? It's going to be 2. That's all we're doing for this. So, going to the planning portion, I'm going to go ahead and kind of breeze through the first half of this. It's mainly the last part that we're focusing on for this video. So that's this. So we have to take an input, have the answer be equal to the number. So that way we don't have a mess up of zeros, multiplying by 0 at the end of everything. And then we check if it's equal to 1, that's 0. Regardless, 0 is a factorial of 1. And so we print out 1. Else we're going to go ahead and go through the while loop that we have num greater than 1. So the way we have that here is our n times n minus 1. So we're going to equal answer. Answer is going to be whatever answer times num, being the number that we inputted, minus 1. And the whole way through, now ignoring these 2 examples right here, I have these from previous ones just to kind of state out what we're trying to do here. We're going to also be subtracting num by 1 overall, because once we loop through this, we're going to always be subtracting num regardless. That way we break the loop and we constantly are making this equation n minus 1 work. All right, and once we break out of that loop, we're going to go ahead and declare our answer again, but this time we're going to concatenate it from integer to string. That way we have access to each of the elements. And now here's the part that we are looking for, and that's this right here. For each letter in I, check if I is equal to 0. All right, so that's pretty much where we have the first 2 portions. And now if I does not equal 0, which is the best case. What we're going to be doing is we're going to be printing out the number, and then we're going to actually, may as well add this in. Then we end the loop. Because it could be like a factorial of 20, and that has like a bunch of numbers in it. Last time I remember, I think there's like 5 or 7. It's one of those numbers. And you want to go through. Otherwise, you're going to hit even more digits because it's a really big number. And that's the whole thing we're trying to avoid. So here's going to be the code that I have stated. So again, number is going to be the integer we take. We declare a second variable adds to num. So we have our two n's. And then here's where we go through our first condition. If num is equal to 0, then we're going to print out 1. That's our factorial of 1. Else, we will, and this is where the second part goes into this algorithm, is while num is greater than 1, so all we have out the way is we're going to be having our answer equaling answer n minus 1. And then we're going to go ahead and we're just going to subtract num by 1 overall. And then we're going to loop back all the way up and down here until we get, until num is going to be equal 0. So once we have that, we're going to go here. Ooh, I see a bug I did not fix on this. So then we're going to concatenate ants to string. And this is where we actually want to delete this part. This we do not need because this is not what we're going to be using. Here's the part that we're going to need is, so what I want to do, what I have here, I didn't state it in the plan above. I forgot to mention it because we have to go at the end. We want the last digit, not the first digit. Is we want to go through this for loop in reverse because we're trying to get the last digit and we're checking if it's not equal to 0. That way that if it's 0, we skip, 0, we skip, 0, we skip. We just keep moving forward until we hit an actual integer number that is not 0. Whatever it is, as long as it's not 0 is what we want in this case. And now that we have I not equaling 0, we would then go ahead and print out that number. So I don't know, 9 is the first number that comes to mind. Print out 9, break out of the loop, and program ends from there. That's the whole way that we're going through this. And that's how this problem is going to be worked with. So yeah, that's how the last factorial digit non-zero works.